Okay guys, it's time for 10.4 solving exponential equations. There's really not any notes for this. We're just going to work a bunch of examples, and just keep in mind that we're not doing anything really algebraic here. It's more of, for the most part, tables and graphs and a little bit of thought. So we'll just start with number 1. Let's look at number 8 from the textbook. So number 8 says basically solve h of t equals f of 6 if h of t is 4 raised to the t and f of t equals 2 raised to the t. Alright, well, so let's just substitute. So h of t is 4 to the t, and we want this to be equal to f of 6. Well, f of 6 is 2 raised to the 6th, and we're not going to do anything else with that. We're just going to write that as 2 raised to the 6th. So now we want to compare these two things. Alright, so what we want to do is we want to have in our head that if a to the, let's say, f of t equals a to the g of t, that implies that f of t equals g of t. So essentially, if you have a base to an exponent equals the same base to a different exponent, those exponents need to be equal. So that's what we want to use here. So can we write either of these as the same base? And the answer is yes. 4 is actually 2 squared, and then to the t equals 2 to the 6th. And then use power to a power rule, 2 raised to the 2t equals 2 to the 6th. So this tells me the exponents must be equal. 2 to the t equals 6 because the bases are the same, and then we just divide by 2. We get t equals 3. And there we go. We've solved that equation. So that's about the most algebra you'll have to use here. So now let's look at number 15. So what's number 15? Let's see. Here it says, without solving, say whether the equations have positive solution, negative solution, a zero solution, or no solution. Alright, so let's look at this. 7 to the x equals 0.3. So remember, the solution is going to be when, for find an x such that 7 to the x equals 0.3. Well, let's think about this. If we do this graphically, what does 7 to the x look like? So the idea here is we let y1 equal 7 to the x, and then we're going to let y2 equal 0.3. This is something we've talked about in class, the intersection of graphs method. So 7 to the x is an increasing exponential function, so it would look something like that. So that'll be y1. And then what does 0.3 look like? See, and well, there's a quick question. Where does y1 intersect the y-axis? Right, at 1, because this is 1 times 7 to the x, so the initial value is going to be 1. So 0.3 is lower than 1, so that would be something like, I know this isn't quite right, but like that. So that can be y2. And remember, y2 equals 0.3, that's the constant function. So the intersection of these graphs, whatever x value this is at, is the answer. So this x. So x is the solution here. So is x positive, negative, 0, or does it not exist? And obviously it exists, and here we're going to have x is negative. Right, because it's on the left side of the vertical axis. Alright, so that's going to be the answer to number 15. Okay, what else do they want you to do? Alright, let's try number 22. Number 22, let's see. It says, construct a table of values for y equals 526 times 0.87 raised to the x for x equals negative 2, negative 1, 0, 1, and 2. Alright, so that's simple enough. So we'll make a nice big table here. X and y. Negative 2, negative 1, 0, 1, 2. Alright, so we plug negative 2 into the calculator here, right? And you should get 694.94. Plug -1 into 2 decimal places, you'll get 604.60. Plug 0 in, that one's easy, that's just 526. Plug 1 in, y'all should be doing this, y'all should have pressed pause if you didn't already and then fill this out. So this will be 457.62. Then you plug 2 in, you get 398.13. Alright, so that's part A, just construct the table of values. And then part B says, use your table to solve, let's see, 604.598 equals 526 times 0.87 raised to the x. Alright, so solve that for x. And it says use the table. So basically here's our expression that we just did all the table values for. So then we look at this number. Is this number a y value? Make our comparisons. Well, it looks like this number. Alright, well, we rounded to 2 decimal places and this is 3. So if we go back and do y equals 526 times 0.87 raised to the -1, we actually get this is 604.598 to 3 decimal places. So this is the one we're concerned with. So then the x value is going to be the answer. So x equals -1. That's simple. So that's 22. All right. So how about we look at 28 now? Let's see, 28 gives you a figure, and it pretty much looks like this. Let me see if I can draw it okay. So the x values, or the t values in this case, 2, 4, 6, and 8. Let's see, we're at 200 as the initial. And then up here we go to 150. And we're concerned with this number right here, 121.55. Or well, actually, maybe it's lower. Wait, is that 121? Oh, this should be 100. I'm sorry, not 200. Alright, well, actually, it's actually more like right here. Let's just do that. And this will be the 121.55. Alright, and part A says, let's see, when is 100 times 1.05 to the t greater than 121.55? Well, here's where we're interested. So if we drew it properly, we see that 100 times 1.05 to the t equals 121.55 when t is 4. So therefore, when is it greater? Alright, well, it's going to be greater when t is bigger than 4. So the answer to this is when t is greater than 4. Alright, and then we do part B. Part B says when is 100 times 1.05 to the t less than 121.55. And the answer here is going to be when t is less than 4. Because when t is less than 4, the curve is beneath 121.55. So here, t less than 4. Done. Alright, great. What about, let's go ahead and do number 30. Alright, number 30 is kind of a big problem. So let's see. So level 5, that's going to be the last one we do, number 30. Alright, so it says, let's graph y equals 500 times 0.8 to the x using x equals -2, -1.5, -1, -0.5, 0, 0.5, 1, 1.5, and 2. Okay, so let's see. So first, we'll use a table to get all these values. So let's see. So x, and this is going to be a pretty big table. Y. So when x is, so you guys go ahead, press pause, write your table out, and get all these values. Alright, so then it's my turn, so I'll plug -2 in, 781.25. I plug -1 in, I get 698.77. That's -1.5. Plug -1 in, I get 625 even. I plug -0.5 in, I get 559.02. Plug 0 in, we get 500. Plug 0.5 in, I get 447.21. Plug 1 in, we get 400. Now I'll just continue right here. We plug 1.5 in, we get 357.77. Then we plug 2 in, and we get 320. Alright, so this is a decreasing function, right? We knew that because the 0.8 is less than 1. So what I'm going to do is just draw a decreasing function. Right? So when we get -2, 781.25, minus 1.5, comma, 698.77. Let's see, -1, 625, minus a half, 559.02. At 0, we have 500. Then at 0.5, 447.21, 1, 400, 1.5, comma, 357.77, and then finally I'll put this one right here, 2, comma, 320. Alright, so we've graphed it. That was easy enough. So that's all part A. So then part B says, use your graph to solve these equations. 500.8 to the x equals 698.77. In the book it says 7.1 here. That's a typo. That should be 7.7. So let me move this over a bit. All right, well, we can use our table for this. Well, where is the output 698.77? Well, the answer is right here. So what's the x value and the y value is 698.77? Well, it's minus 1.5. All right, and then it says 500. Here's the other one to solve. Times 0.8 to the x greater than or equal to 400. Well, here's the output is 400. Well, where are the y values bigger than 400, to the left or the right of 1? Well, the answer is to the left. All these are bigger. So the answer is going to be x needs to be less than or equal to 1. Okay? So there's the answer for those two. All right, and that's all we got for today. So I will see you guys tomorrow. Have a good one.